Going live. All right. Okay, we're about to get started here. All right, chat's up. Timer's up. Let's see if we're actually streaming. It looks like we're actually streaming. We're on the YouTubes. And yeah, so we'll go ahead and get started here in just a second. Okay, got 50 seconds left. All right, and we're ready to go. Let me go ahead and get this thing started. All right, everybody. Hello and welcome back. So we are going to continue with this Golang TLS router. Hold on, let me actually check sounds real quick. Okay. Looks like we got good sound, good volume, good everything. So we're going to continue with this. And I realized what I'd done wrong when I created the flags. Hold on. First, let's pop a top, my friends. Whoa. Whoa. Couple of sprays of Mountain Dew. Went somewhere other than the cup. That's no good. Oh, well. We'll work it off. All right. There we go. And I am still going to be doing the Proxmox videos. I didn't take a break from them. I just had some things happen, like my laptop being run over a few hundred times, that set me a little back. So, and this is just something that is a pressing issue that I need to solve for myself. So that's why. Anyway, so last time was basically boilerplate and a very, very simple, the hello world of TLS. That's what we had last time. So if we take a look here, this is basically what we did. We created a proxy function that takes in a net connection and then checks to see what the TLS hello is. and prints out server name and supported protos, which is SNI and ALPN. So that's it. That's all we're doing at the moment. And then in terms of why was my parser not working for the flags, very, very simple. Because I did a parse of os.args rather than os.args1. So now I imagine if we build this again and run it, we'll see that it starts up on 4433. So rookie mistake, just a little oopsie, but all's well now. And I actually want to tighten that up. So I'm going to go ahead and commit that. Alrighty. Oh no. You know what I'm going to do? You know what I'm going to do? I'm going to copy this and I'm going to force push over main because I just don't like what I did. I don't like that I made an oopsie-lo. So we're going to fix it. Oh, whoops. 2. There we go. Oh, really? Oh, okay. Interesting. We're just going to fold that bad boy in and we're going to drop that one out. Let's see what happens if we push. There we go. So we can drop that, we can drop that, and that should apply cleanly. There we go. All right. So now, let's consider what we have to do. Now, I've done this once before, so I think I might just go grab that file, or we might redo it. But basically what we need to do is we need to wrap this connection so that we save those bytes, because we're going to need to forward those bytes. Let me see. Let's just say that we're going to do a straight pipe of this. What would that look like? We'd actually have to have 2 go routines, one to handle incoming traffic, one to handle outbound traffic. I wonder if there's a better way that we could do that. We could select on channels. That's another way that we could do it. Let's see. So I'm just thinking out loud here. No, because we still need a go routine either way, because even if we're going to select on channels, we'd have to have go routine for the channel to be in. So, So we're doing a go proxy here. And the reason we're doing a go proxy is actually so that this defer close can happen. But this might run for hours and hours. Oh, we also want to count bytes and stuff too. So we want to have some extra information. And I think it would be really cool to get the information in a way that we could have a time series and graph it and say what type of, how much data is this thing using, and what's the bit rate essentially. But I don't know if I actually want to do that. Anyway, so what are we gonna do? We need to be able to let this connection read, but whatever is read, we need to put away for later. So let me do this. I am actually going to go... I think AI might be able to do this one for us. Alright. I need to... I'm writing a TLS router in Go, and I need to wrap net.con so that I can track, well, so that I can pass it to TLS.server and perform the handshake, but still, and then be able to write those bytes into a pipe. Let's see. Without losing those bytes, and be able to write them into a pipe. I'd also like to keep a count of bytes read and written, as well as the connection time, and I'm open to suggestions for other useful data to track. I don't like that it did that. Oh wait, no, that makes sense. But I don't actually want to do that. I don't care about handshake time. I don't care about handshake error. I don't think we're going to need to worry about mutex. So read and write. Okay, that makes sense. Read, but wait. Pretty sure that we're not going to do any... I don't think we need that atomic counter. Because, do we need it because we might want to look at what the bytes are while they're being updated? Maybe. Let's see what else. Close. What would this lock be being used for? Let's see what it's using the lock for. All right, TLS con, t.con, IO copy, form the handshake. Wait, it didn't keep my... Oh, it didn't keep my buffer. Okay, well, that was kind of useless. I guess I should just write it myself. All right, so we're going to create... we'll just call this con as well for the time being, and then we'll... Hey, how's it going? And then we'll consider as we go. So... Or is it just struct con? Expected... Okay, type construct. There we go. All right, and this is going to basically be net.con. And what else will we put in here? Bytes read, bytes written. I like the idea of using atomics for that. I don't think that's the way that works. Is that the way that works? Atomic, and then we add? Hold on. Let me go look here. All right, sync, atomic. By the way, how you doing? Huh. I wonder how that works. Because we're just passing in a normal... Alright. These functions require great care to be used correctly. All right. Okay. I kind of want to learn about this right here. Add uint64. Returns the new value. Okay, that's what I was expecting, was this. That we would have an atomic uint64. Okay. So I'm just going to put here atomic uint64, and I guess that would be a pointer type. All right. And then I suppose I could put a mutex around that, but I like the idea of this better. And then we can do a load. Loads and returns the value. Yeah, that sounds good to me. I wonder, is it possible? No, it's got to be a pointer. Okay. Or maybe the mutex would be the better way to do it. Because it seems like if there's a lot of bytes going on, then this would be kind of, All right. Following example shows to maintain a scalable, frequently read but infrequently upgraded data structure using copy and write idiom. Okay, example, mostly read. Do we have a write mostly? What's up, Tyler? So what I am working on today is I am making a TLS router in Go. Oh, how do I move my cursor so fast? Okay, let me do more than one thing at a time here, or only one thing at a time here. So I am basically I want a reverse proxy, but I want the option of whether or not it terminates TLS, meaning whether or not it loads, whether or not it forwards to another place before it tries to figure out which certificate to use and how to do the handshake. So basically, the ability to do end-to-end encryption, where the reverse proxy doesn't actually decrypt the traffic, it just inspects the SNI header and the ALPN protocol information. So it's similar to what you have with a web server reverse proxying on the host name, but this is reverse proxying at the TLS layer rather than the HTTP layer. So you could also tunnel through this things like Postgres or SSH. Postgres now supports ALPN and TLS, and SSH does. You have to tunnel SSH, but you can tunnel SSH just fine. How do I move the cursor so fast? Yeah, I don't know how people use a computer without doing this, honestly. But it's in the... Let me see if I can go to it and then bring it over here. So it's in the trackpad settings. Oh no, not the trackpad settings, the keyboard settings. So in the keyboard settings, you can see that my key repeat rate is fast and my delay is short. So I actually set this via the command line because you can set it faster and have the delay shorter than you can have in the UI, but that's what I did. Also, I turned off all this text. No, that's not the text replacement. I added a couple of text replacements here. There's some stuff. Where is it? Input sources, keyboard shortcuts, edit. Is it edit? No, it's not that. I thought it was in here. Input sources. Here it is. Under input sources, you can also turn off smart quotes and autocorrect and stuff like that. So being a coder, I turned that off. But yeah, I find the regular rate to be way too slow. And this is not actually as fast as I have it elsewhere. But it's sufficiently fast. I think let's see. I think in Sequoia they may have changed what the values are for this, and I haven't updated to Sequoia yet on this computer. So, and also I have a actually let me see if I can bring up the gist real quick. I'll share this link with you because I'm not using the arrow keys. I'm pressing left shift command, and then using in my case it's J and P, but I use that because I'm using Dvorak and that maps to H and L. So okay. Yeah, I'll give you this link here and I'll bring it up. Boo. So I'm using Carabiner and I'm doing a couple of things. So I have some key mappings that I like. Did I put the website where I got that? Yeah. HID util generator. So there's some key mappings that I like. It's basically backspace, forward space, enter and escape. I've remapped to caps lock, delete, right command, and right option. And then with Carabiner, I've done these 3 remappings, which allow me to have a modifier key of left command, left shift, and then map that plus J, which is the physical key, to left arrow. So J is not the Dvorak key, J is the physical key. Key code refers to the physical key. Anyway, so there's that. I'm going to ask Grok what it thinks about this particular choice. Whoops. Where did Grok go? See what it says. Lock free and optimized at the CPU level, making them extremely fast. So below is thread safety. Guaranteed atomic updates without need for explicit locking, avoiding race condition. Okay. Okay. So it both increments and returns the new value. Okay. Really? Same performance and thread safety benefits. More idiomatic. Yeah, I don't care about the verbosity. Okay, so this is actually locking. I am using Go 1.19 plus. Okay, so it is saying, I don't know if that's true, but what it's telling me, whoops, what it's telling me, it doesn't quite make sense. Okay, let me take a look at this again. So type. So notice that this is the pointer. So this says type int64, and this gives a. This shows up it being having a pointer. That doesn't quite make sense to me, because it seems like you'd have to dereference the pointer in order to use it. That's where I'm a little confused by it. I'd like to see some examples. Do they have any examples? Added in Go 119. Wait. Oh, and okay. I don't know if that's true. I'd really be interested to learn more about this. That's the thing I don't like a bit about AI, is you never know if it's true. You know, you don't know what you're really reading, because it doesn't quite make sense to me that if I have a pointer to this, I don't know. We'll just go with it for now. All right, so we're gonna have this struct, and we're gonna have a func. And it's going to be C con And what is it going to be? Read in, and it's going to return, well, I guess, what is this actually supposed to be? It's going to have to be byte, and then it needs to return int and error, I think is what it is. Let's double check on that. I think that's what the reader API is. Read. Okay, go reader. Okay, we're going to read into an array of bytes. And we get back, yeah, okay. Just making sure I'm not rusty. C.read B in error. Whoops. Well, I guess, let's see, okay. So we're going to do C.bytes read. Oh, you know what else we got to do? We have to somehow... maybe I could just have this. No, I can't do that, can I? It's just kind of weird to me that that's not a wrapper type, because now I have to instantiate this somehow. So now that means that I need to have a new con function, right? And then the new con function is going to have to take net.con, and it's going to actually return a pointer to con. Whoops. And then we're going to have C equals con. Whoops. Can I do it like that? And then for bytes read, we would do atomic.uint64. Which in this case, it might actually make sense to use new, because we are actually dealing with pointers intentionally. So okay, bytes read dot add in, and we don't actually want that back, and then we're going to return and I don't know if I really want to do it this way either. I think what I actually want to do is, rather than try, well, I guess what I could have is, okay, we could have a peak here. I think this is how I implemented it last time. So we're going to have a peak, and from that, we're going to do this read bit, but we won't increment the read counter. And we will have these, and to think. So we make it with a certain capacity, but then we determine what its length is by how much we read, right? So well, I guess this should be pretty rare. Well, yeah, we won't try to optimize this, because this is going to be the weird case, right? So we're going to take a slice. Oh, wait. Not this. We're going to do this. We're going to do it like that. Okay. So here we're going to make this with a size of 0 and a capacity of 1. I think that's all we're ever going to use there. Now, technically, those operations could fail because there's memory allocation there. But that's, I think that's just a panic and go. All right. So we've got a peak operation. The peak appends to the buffer. And, you know, I don't even want to expose that publicly. And I kind of just want this to be a one-time thing. So we're just going to do it like this. Oh, and then we need to adjust that make as well. And I'm going to say that this is going to be up to, what's the typical TLS hello size? 300 bytes? Typically, so, okay. So let's just assume that it's going to be 512. Just to make it a power of 2 number. Okay. Well, I guess, let's see. Technically, yeah. There's a bunch of edge cases that have to be dealt with here. That's the problem. I think what I'm actually going to do is I'm going to create 2 structs. One that's going to be, we're going to call this one HelloCon. And then I'll just copy it over once we're done with that. And we probably don't need this to be the same. So, okay, this is what I'm thinking here, is that we're going to need a HelloCon for the connection, what represents the connection before we do the hello. And then we're going to need the con that's after the hello. That's the normal connection. So we will have buffers like this. We will have this be 1. We will have that return HelloCon. I don't think that we'll do this in here. We'll save that for the other one. Okay. So this will be a new con. And then here we'll take in a HelloCon. And then we'll return a con. So we're going to take hc.con there. And then we're going to do bytes red dot add, and then we're going to give it the hello con dot buffers. Let's see, for okay, bytes read. The reason I want to do this is I actually want to handle the case where somebody is using a debugging tool and they actually start sending data over the wire prematurely before they've formed the whole hello, because I like the idea that debugging tools should work, so I don't expect the whole hello to come in a single packet. Normally that's the way it would work, but that's not what I don't want to enforce that. It's reasonable, I just don't want to enforce it, so I want to have this hello con that can be a little less efficient. And then, let's see, so all right. So this one's not going to have buffers. And HelloCon will have buffers. All right, and we're going to make this uint64. There we go. Okay. So let's get our stuff straight here. So there's our con, our new con, our hello con. All right. So when hello con reads, it's just going to read into a buffers array. So we're going to do hello con is going to be hc dot buffers equals append and if I remember correctly, this is non-inclusive because we didn't want to have all the off by one errors, right? You can tell I haven't been doing enough programming in Go lately. Wait. There we go. Okay. Up to 5, 2, 5. All right. What was this? We're creating the string what? Bar S string. It's got multiple strings. Okay. Set get. Okay, append DEF. So now it's 6 long. Okay. So what I want to know is what does the 5SL2 A, B, C, D, E 1, 2, 3, 4, 5. So it prints up to but not including 5. Okay. And then 1, 2, 3, 4. SL3 is 2 through the rest of them. Okay, got it. All right, just making sure. Just making sure. Okay. Oh, this one we're not going to have to do here. Let's split this again. All right. All right, we're not going to worry about buffers here. We're just going to add the bytes read. Yeah, there we go. Okay, so this one, we're not going to have the bytes read. We will put connected here. No. Hold on. What did I do? Hello, com. All right. Okay, bytes read. We're not going to do that one on this one. We're just going to append the buffers and then... Oh, it's just griping about something that's not there anymore because I already deleted it. And then HelloCon will not have a write method. Well, it will. But it will just panic. Yeah, okay. Okay, buffers is unused. Yeah, we're not going to use that one. Okay, I actually do want to put that down below for whatever reason. All right. Actually, you know what I want to do here? I just want to take in net.com. I'll leave it for now. Because this is pretty... It's pretty specific what we're doing. Okay, so we've got a copy of this. Okay, right should not be implemented. And then I want to go take a look again at netcon. I think it's what I was looking at here before. Nope. Let's look at net. There you go, con. What is the interface? Read, write, close, local, adder, blah, 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 blah. So basically, I just want to overwrite some of those. All right. Now let's take our little function that we've got and say we're going to go proxy the con, and we're going to have a hello con, which is going to be the connection, and we're going to pass in HC. All right, what does it not implement? Oh, duh. All right, and I think that we'll probably make this type an internal type. Anyway. Okay. So let's go back up to where we are doing the proxy function. All right, so we're going to create a new connection there. And probably do want to put some deadlines on this. And the error that we want here is stop handshake, and we're going to check this error. All right, we're just going to leave this one here for now. All right, so at this point, this is where we're going to do the piping. What could I do with this thing? Oh, whoops. There we go. Okay, so I think that this is basically what we need to get started. This con read is going to have to... Let's see. This actually may need to have buffers. And then if let's see. All right, so when we create this new con, this should be nil. And then if we have the length of the buffers is greater than 0, then c.buffers equals hc.buffers. Oh, not only that. Well, yeah. And then we need to copy. I don't know if that's correct. All right, so I think that's about right. Except I probably want to invert this. Because the happy path is that buffers are nil. Okay, and let me make sure that I got the arguments in the correct place for copy. Okay, copy. So make this length of s, copy this one into this one. Into, yeah. So the target is the first argument. That makes sense. All right. How's it going, everybody? All right. Okay, so all right, so when we pass in the net connection, we're just going to make some buffers. And that's about all we're going to do. And then we're going to set up that whenever it reads, it copies whatever it reads into buffers. Let's see. Does this start out as nil? This should start out as nil. That should just be nil. Because if we do the length of nil, then we get 0. And if we do a nil check on nil, we get nil. So that actually should be just fine. And when we do the append of nil, then that creates it if and only if it needs to exist. Well, I mean, I guess, okay, this is where this makes sense, is most likely we're just going to need one. So actually that does make sense to be there. It's not really possible for us to not end up with any buffers because we got to read the hello, so we got to get at least those buffers. Okay, but we're not going to allow writing or closing. So let's go ahead and run this and see what happens. What might happen is it might actually call close when there's an error. So we might get a panic. Okay. HelloCon does not support write. Ha! Okay. Oh, interesting. All right. So apparently what we're going to need to do is return 0 and this error. Let's see here. Interesting. So here we got a stop handshake. Whereas... Okay, I'm a little confused by this. HelloCon does not support write. Versus stop handshake. Huh. Was it going to write a close message? What was it going to write? That's what I want to know. Let's see. Let's find out. Oh, whoops. So we are going to need to do that. Okay, so let me see. What does this look like? This looks like the length. This looks like an ASN1 type. This looks like an ASN1 type. This looks like a... I don't know. Okay, let's see. Let's ask Grok. Bah! Well, what? I believe this is an error in response to a TLS handshake. Can you decode it for me? All right, 1 byte. Okay. Alert. Payload's 2 bytes long. Fatal. Unrecognized name. Okay, cool. Neato. Okay, so maybe... Let's see. Let's say... Let's just do a general search on this as well. Back in the old days, you used to be able to do searches on hexadecimal. But I think that Grok might be right here. We could also cross-check with Jippity. So let's do that real quick. Let's cross-check with Jippity. I'll give it the same prompt I gave Grok. Well, all right. Decode error. Okay. Okay. All right, so let's go back to our proxy function. We're doing the TLS handshake here. And we're supposed to return a TLS config if we can. So this is where we need to be able to read a JSON file. So let's go back to Grok for a minute. I'm just going to get it to generate some structs for me, hopefully. Actually, hold on just a second. Let's see here. Okay. JSON to go is the better way to go for this. So, okay. Let's just consider what we might want the... Let's say the domain config here. Type domain config struct. And what we're going to want is to have a list with a bunch of names. And let's see. I'm going to ask Grok a question that it might know the answer to. Let's say, at what point is hashing is let's say a map in Go faster than... All right, let's see. I have a bunch of names that I want to... have a bunch of configs that have a string ID, and that's usually between 10 and 20, or let's even say, you know, 6, 5, and 15 characters long. In Go, at what point I'm considering whether to use a sorted array or a map for the config. At what point, let's see, go slice binary search. Oh, Arden Labs. Look at that. Okay. Really? I'm pretty sure the standard package has this now. Yeah, binary search is there. All right. My guess is that for the sizes that, for less than 10,000, it's, well, one, it doesn't matter, but it's probably faster for using a binary search. Well, actually, even the extra effort of doing a binary search, for up to a certain point, let's see, because with hashing, you're doing a lot of operations. Anyway, I have a bunch of configs that have a string ID that's usually blah, 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 and characters long. Go. I'm considering whether using a sorted slice of configs or a map of configs. At what point would I'm going to ask Jippity the same thing. Okay. 50 to 150 cycles. $10 to 20 cycles per comparison on modern CPUs. Yeah, so actually binary search is pretty much almost always going to be faster. So you got to get into the hundreds of thousands or millions. It looks like. I mean, even then, you know, so that it only goes up by a few each point. Wait, that didn't make sense. It contradicted itself. Okay. Sequential memory access. I kind of want to think about what information is necessary in order to be able to do what needs to be done, because we could take, if we can optimize for the information that tends to be necessary, then we could put that close together and then put the rest in pointers, but it kind of depends. Huh. Slice. Really? That I don't believe this is right. I think that that's wrong, because if that were true, they wouldn't have bothered implementing it. I think that what looks more right to me looks to be something like this, where the binary search ends up being much faster. But then there's also the issue of just not doing a binary search, just doing a search is going to be faster. So anyway, this is going to happen a lot. So in the beginning, will it matter that much? No, but it is kind of... What? Yeah, I'd have to run a benchmark on this, because that just doesn't seem right to me. Okay, this is what I was expecting. Oh, it doesn't talk about maps at all. Okay, anyway. The other thing that we got to consider is that these being string values, we're going to lose some efficiency there. If it was fixed size, then binary search seems like it'd make more sense, because then you get more cache alignment. But I don't really know a whole lot about that yet. Anyway. All right, domain config. All right, I'm going to do configs is a map of string and domain config. And there's a bunch of other stuff here. Like right now, this is a singleton, but that's going to be okay. Whoops, that's not what I wanted. Let's try that again. Okay, cool. So there's configs. And then here's my nice empty struct. Ooh. I gotta think about we're not gonna use an asterisk, we're gonna use a dot for Okay, we're gonna have hosts, and we're gonna have a host config. Terminate TLS is gonna be a bool. Adder is gonna be a string. Port is gonna be a string. TLS is going to be a bool. Server name is going to be a string. ALPNs is going to be a slice of strings. And then Acme config is just going to be nil. Can nil be a type? Nil is not a type. So I'm going to make that star n for now. We'll just leave it out. It's just a to-do. I mean, I guess we could just make it an empty struct. There we go. How's it going, everybody? Been working a lot lately, and so my energy level is a little lower than usual because I've spent more of that energy already during the day. So my apologies for not the most fun stream in the whole world, but if we get some conversation going, it could be. Okay. Okay, I got a question. Your reverse proxy would allow for secure self-signed certs on the back end instead of just turning off certificate checking? We could do that. Okay. Let's see. All right, I'm gonna ask Rock this. I want to supply trusted certs when making a TLS connection in Go. What would that look like? Cert pool, that's what it is. Okay. Read file, CA file, read the PEM file, new cert pool, append. So I actually don't want to append to a pool. Okay, okay, it's just saying append those certs to a pool. Load cert pool. Yeah. TLS config root CAs. CA pool. What about chain though? Well, I guess the chain should be given. Okay, yeah. Okay. So what would this be considered? Read file. Append certs from PEM. Okay. I think that's what that would look like. So we're not going to handle all of this right now. Ah, this is something I hadn't thought of before, but this actually makes a lot of sense. We can have... well, we could match on server name. How would I want to do it? Would I want to have a little list of ALPNs and then have them each copied in? Maybe. Okay, I'm gonna have to think on this a little more. But essentially none of this is relevant right now, and I'm not sure whether or not server name is actually relevant. Okay. Okay, something like that. Something like that. Anyway. We'll model this out. This way we'll get some JSON going. I'm wondering what the best way... Oh. Basically, if it's been more than 15 minutes since I last checked the certificate, I'd want to check for certificates again. Yeah, we're gonna have to have something where we reread the config regularly. And if we error when we read the config, then we don't try to replace it. But we're gonna have to have something like that where the config, we're actually gonna need some sort of mutex around the config. I don't like the idea of that. Blah. Well, it'd be extremely rare. Well, let me ask. Okay. I have a config that I'll need to replace every 15 minutes or so. Would I be better off using a sync.map or a mutex? I'm going to also give Jippity the same question here. Again, just kind of hoping that it gives me a good answer. All right. All right, that's fine. What if this is true? So sync.map is likely to be much faster for something like a config file. Again, I just don't know if I trust this, though. I don't know if I trust it. Okay, what would atomic replacement be? I don't know what that means. That did not make sense. Replace config. Yeah, get config. This is what I'm worried about. What's up? How's it going? All right. Load. Yeah, I don't even worry about that so much. I mean, I just... Yeah, I just want to replace the entire config. All right, let's see if this agrees. Interesting. So Grok and Jeopardy disagree. So I should have done a search on this. So let's look at sync.map versus sync.mutex versus atomic.value or high reads. Because I thought that I saw that sync map and map with a mutex were actually very, very similar. So 3 years ago, okay, so this isn't too old. Let's take a look. Yeah, okay. Oh, speculative answers. Concurrent map. Interesting. So mutex seems like it's fastest, other than concurrent map. And this was for how many operations per second? You know, another possibility here that actually makes a lot of sense is that the config, so you can add a new listener and then you can close a listener down. So, for example, let's see, Golang listen on existing port. Okay, I don't want to listen to this song. All right, Golang multiple listeners on the same port. Oh yeah, that actually I saw that just before it was reuse port. Reuse adder. All right, 10 years ago. Because I'm pretty sure Caddy does that. I think that's how Caddy solves the problem. Okay, listen config. Config.listen, reuse port. Okay, got it. That makes sense. Should have just gone straight to the source instead of doing all the searching. Alright. Reuse. Config. Listen config. What? Okay, let me reopen that again. Because I think I missed something about how this is supposed to work here. Oh, nope, I don't want a bookmark. Oh, bother. Ooh, I wonder if this makes it Linux specific. Hey, look at that! Look at that! Ah, there we go. There we go. Oh, that's always that. Only the best of people are found in search. Oh. So, for those not in the know, Matt Holt is the caddy author. There we go. Can't get away from him. He's everywhere. Always 10 steps ahead of me. Oh. Okay. So can we do this for Windows as well? Okay, it's the same. Well, all right, it might be different. Reuse adder. Do we have reuse port? Okay. So reuse adder. Okay, so reuse adder is actually a different number between the two of them. Interesting. Okay, so we might need to have a Unix versus everything else here, or Windows versus everything else. Because under sys, yeah, we just have Unix and Windows. So I don't think that's going to be too much of a problem, actually. So we should be able to do this. We're going to have a TLS router, Windows, and so we're going to have netlisten config control. What does SOL socket mean? I don't need to worry about that. Okay, can control return an error? Yeah, it can. So I think we... Okay, let's go back and take a look. Where were we? Hold on. Let me go back over here and take a look. No, not that one. Okay, now I can close out some of these. So I don't want to have to add a mutex to this. That's not a great pattern. The better pattern is going to be to close out to add a new listener and close out the previous listener. So that way, whenever there's a config change, we just do a bunch of cleanup. Okay. Oh, I did want to keep this open just because there was 2 typos or mistakes that I had in here. Typo might be a little too generous. They were just straight up mistakes. I want to remember to fix that. All right. So control can return an error. Yes. All right. So okay. Con. All right. Wait. Control is a function. Network address syscall error. Okay. Control. Control. Ah. Okay. Whoops. Gotta go look at raw con here. Control. And this is going to be different. So I'm going to call control with this function. Okay, control invokes F. Okay, so what set sock? Hold on. Let me go change this up real quick. So Unix. All right, netconf.listen. All right, let's go back over there. Where did it go? All right, net.listen config. All right. So we're going to say control is reuse adder. Reuse port. Reuse port, reuse port. What do you mean not? What do you mean not defined? How is this not defined? What are you talking about? I just defined it. What is a packet con? Ooh. Huh. All right, I don't need that right now. Okay, so I do like the idea of having a context that we can call. So that we can close this when we want to. see. Not cancel the parents console. Okay. Let's see. It is never canceled. Has no values. Let me see here. Return background CTX. Okay, don't I want to cancel one? I want a cancelable with cancel. Okay, I'm feeling kind of dumb right now because I do not remember this. Context with cancel. Okay. Context.background. Okay. Okay, right. Okay. I don't know why. I was not remembering that. Okay, that makes sense. So we're just going to create a context. Not sure what we're going to do with the cancel yet, but we are going to do listen and put the CTX there. And then let's see, why is it telling me? There. To do. All right, was it timing? I'm getting this error in Vim, even though the function is defined in an underscore unix.go and underscore windows.go. file. So I'm going to have a plus build Windows. Okay, let's try this. Build tags Unix. Let me try that. Just a second. I'm just going to put Unix as the only build tag. Okay, cool, that fixed it. Nope, it didn't. Okay, I'll try... Let's just try this. Okay, that one seems to be happy enough. Hmm. I wonder if I can just define that somewhere else. Oh, and then there was something... There is an actual thing that goes here for basically none or never. I don't remember what it is. But it's a pretty intuitive name. Anyway. Let me do this. All right, I'm gonna try this one more time. Yeah, I don't know what to do about that. That's gonna bug me, but I don't know what to do about it. So I guess I'm just gonna have to live with it for the moment. All right, anyway, so we got the control, we got the reuse port. And I don't know about this. SOL socket. What is SOL socket? Socket level set to SOL. Okay. What is this for? Is this just for Unix? What is... Okay. Okay. Yeah, that is what I want. I like that. Oh, I see what's going on here. I see, I see. I don't know if that's how that works. It looks like that might work. Let's see, incompatible sign. Ah! Can I use FD as a syscall handle? Alright, why is this wrong? Okay, I am a little out of my depth here. Let's go to the Unix one. This okay. So this one's not griping so much. Okay, so let's go check this out. I wonder why it doesn't accept an error. I would love to see more examples of this. I'm going to ask Jippity the same thing, because this is something where I actually don't know what the right call is, and I don't have enough information. Whoops. How's it going, everybody? Feel free to say hello and stuff, because it always gets more fun that way. Okay, I'm a little confused here. I need to go back to what I was looking at before, see if I'm missing something. All right. Oh, okay. Okay, there may have been a red herring here. It looks like this is just going to do the right thing regardless. So I don't think that I actually need the... I don't think I actually need the Windows specific one. I think it was just for an older version of Go. Let me go check this out again. So if we look at the syscall package, yeah, because they're not implementing. Okay, so my guess is that this is actually being made to be portable, and it may actually be different. Let me see. So if we go take a look at the constants, we go look at the source code for this. I'm actually expecting that there's going to be a Windows and a Unix. Yeah, see, exec Linux. But if we go look at exec Windows, then if we look for SOL socket, no. Okay, I think this is... Okay, there we go. So syscall is portable. We can see reuse adder is the same almost everywhere. It's different on the interesting. Linux is the odd man out here. Okay. Okay. So I was actually misunderstanding. I was going down a wrong road. So this one, SOL socket, Windows is the same. Linux is the same. Okay, cool. All right. So this code is actually the better. This code is correct. This is correct. So let's go back. Does it say when this was added? I'm not understanding what that other message was then. Or 1.9. So, but that's been there a while. Okay, I would like to see the commits on this file. Can I see? If I go back to Go 1.9, what am I going to see? So reuse port. So this, I don't know, this looks like it's been here. Oh, no, okay. Got it, got it. So it was not always there. So let's look at Go, let's say one, I don't know, let's look at 111 or 113. Okay, it still wasn't in there yet. I'm just going to do a little binary search here. So Go 114. It's not there. What about Go 116? Oh, it could have been there. Never mind. I'm looking at the wrong thing. Again. Okay. When was added to the syscall package in Go? All right, that doesn't matter though. We're going to carry on. Has been frozen. Are we? Hold on. Okay, what's going on here then? Because I definitely see that that's working. All right, I want to look at this. Going. Okay, now I'm having a little bit of trouble here because I definitely see that that's working. Reuse. Okay, that's definitely there. Okay, so where's syscall? This can't be right. Because didn't we just see Linux exec? I am so confused right now. Source syscall exec Linux. Okay. I am so confused. What am I looking at? Oh, I'm looking at a specific commit. Okay, so let's go to master instead. All right. What is going on? What timeline is this? Hold on. SO reuse port. Oh, no, go back. Okay. Ah, no, go back. I am so confused because it very much seems like okay, whatever. We're gonna move on. We're gonna move on. How I just don't understand how this seems to be correct. Okay, but configs is unused. Whatever. What is this complaining about? Return value is not checked. Okay, whatever. Whatever. All right, anyway, so we got our configs. We've gone down some rabbit holes. So we're probably going to do a type server, or I guess listener. There we go. So then we'll have a func new listener. We're going to do type alias here. Just so that we can start using listener config. Whoops. Config. We might want to create an interface that just has a listen method, maybe. Well, I guess we don't. We can return a concrete type because that can always be used as an interface, so we don't have to worry about that. All right, so okay, there we go. Listener's going to listen. And we can, of course, close the listener. Okay, so then we got a server there. I do want to just try something. Okay, good. It does agree that bananas is not there. But it does think that reuse port is there. So that confuses me a little bit, but we'll see when we go to compile it. Anyway. Bah. Okay, what do we call what comes off of listen? Is that not a server? Listen? Listener. Okay. Listen. Okay, so then what comes off of this then? When we listen, we get back a listener. Then what gives us back? Alright, okay. Hold the phone. Alright, this type is just config. So then this is a listen config. Is that right? I don't know. Which means that this is just a config. Okay. All right, so this has a listener. Okay, but we need a way to close this too. Okay, but we can't really do anything. So the config is going to have the cancel in it. So we're going to have to put the cancel there. So let's go back to the main config, new listener config. Actually, this config is not going to be public because you're going to have to create a new listener in order to change the config. So, context is going to be CTX. And cancel over cancel. And that won't be listener. That will be C for, well, I guess LC? I don't know. There we go. Now we're getting closer. Let's see. How does it handle it here? So you got a listener comes back. Does a listener have an accept, a close, and an address? Okay. So that makes sense. So this should be... All right. Good old rapid network stuff. All right, I think we're almost ready to test this again. All right, so let's see what we've actually done here. Not a whole lot in the last 3 hours. Okay, so we have a domain config, which we don't yet have a way to use. Hold on. So let's go back into command here. Let's just save this, and I'm imagining, yeah, there we go. I'm just going to have Jeopardy rewrite or take in this config. Let's see, host config. There we go. And by Jeopardy, I mean Grok in this case. Write the go function to read in a config file and parse it. A JSON config file. Parse it according to this struct. Of course, let's see. Read config, OS read file, unmarshal. Yeah, that sounds about right. That's good. I like that. We should probably separate this into a read config and a lint config. So let's do that. And the lint config should probably go into the library. TLS router dot lint config. Well, I probably should put this one level down. Make this like struct. I kind of want to call it map. Actually, no. Let's see, domain config. I don't really want to call this host as much as target, because that's what this is really about. It's what's the proxy target. And what this would really be Okay. All right, that looks good then. Okay, and you know what else we need in here? We need stuff like active status. Well, okay, so I guess there's a difference between config and status. I guess we could just do... how do you do health checks then? There's a question for us. How are we gonna do health checks? Thinking about this. I wonder what the right way to do that is. Because that's something that we'd want to check frequently. But it's possible... Yeah, because that seems like we'd have to do... That seems like we'd have to do a read lock. And if we have to do a read lock on that, then why wouldn't we just replace the whole... allow updating the config? Maybe that's something that we could do with a channel. No? Alright, we'll track some status. Okay, we're going to track whether or not a target host is active in memory, which means that we'll need to read the Boolean status frequently and occasionally update it. Okay, so we're just going to do the same thing again. We're going to have an atomic that specifies but this one's slow. I need to learn more about this. Okay, so tell me this then. Explain the explain how atomics and mutexes work at a low level. Okay. How is this possible? Ensure all cores. Okay. Okay, mutexes. Where does it talk about mutexes? Oh, hey, how's it going, everybody? I am learning about the lower level implementation of mutexes and atomics. I don't know if I'm getting... This is the thing I hate about AI. I don't know if the information's correct, but I don't know where to go to get better information. Because search is pretty much dead. But I wanna understand better the difference between an atomic and a mutex, because it would seem like an atomic is just syntax sugar for a mutex. Okay. So at this point, we're going to keep this all in one file for now. I want to get to a point where we just test this and then I close up shop for the night. I'd like to do that within the next half hour. All right, so where were we? Ah! Okay, so. All right, so TLS router config. It's going to be this. Let's see. We need to add to our list of options the config file to use and come up with a decent default for that, like what we have here with the bind. All right, there's the config JSON. env config. Kind of doesn't even make any sense, but we're gonna go with it. Big file. All right, so now we've got config path. All right, so we're going to have this, an error. If error not equals nil, then we're going to log.fatal add mojanker. All right. Boom. Oh, I messed that up. There we go. All right, so we got ln config listen, and that's ah. All right, and then this one we need to do TLS router dot domain config. Yeah. So I think what we're going to do is we're going to iterate over all of that, and then we're going to reshape it more nicely. Okay, let me check and see what I did here. Lent config. All right. Or I guess this should technically be... Do we make that? Okay, and then for config... So first we... Lent configs? Yeah. I don't know. Configs... Range, whoops, range configs. Alright, so if this is really exists, well, first of all, domain should be so I want to get rid of a star if there's a star there. Well, let's even go one further. So we got strings has prefix star. If not, has prefix star dot. Then we're gonna I don't like having warnings coming out of a listener. That doesn't make sense. We're gonna correct that, but I'm not sure what way we're gonna do it yet. All right, so whoops. There we go. All right, there we go. So now we're getting our domain is getting set. Let's go over to the lint. Okay, so we'll move that. We move that to the lint config, and then here we just strip that. We don't worry about there being an invalid domain. Okay, so then I kind of want to build config function because there is still some stuff that, yeah, there's still some linting that I want to do. So for example, if exists, yeah. We still have a problem. All right. All right. Why did I decide that I wanted this to be array rather than a map? Oh, because I wanted the domain to be one of the properties, and I didn't want it to be both. I wanted the JSON to be able to parse easier. But maybe this is pointing to that's not a good enough reason, especially when we can just transform at the beginning. You know, if we have to have a duplicate struct that's very similar and we have to do some transform, whatever. Who cares? Undefined strings, what? Don't we have a strip prefix? What is it called? Trim prefix? There we go. Okay, so maybe, because we want it to be really easy for the user to not make mistakes. That's kind of important. So we probably do want this to be a map. And then, you know, the unfortunate thing is we're just going to have this, we're going to have these similar structs. So there'd be a domain config JSON, for example. Well, I guess it wouldn't matter. It would just be domain config. And then as we go through, okay, so let's consider it like this then. Let's consider it's like this. So then we would have domain, and then we would see like this. Okay, that would be fine. So then and then we have some JSON tags here. There we go. It can be an empty. That's essentially now a Boolean. It can either be nil or it can be empty. Oh, strong JavaScript vibes right there. It can be not defined or undefined. see. Okay. Oh, you know what I don't like about this? I don't like the idea that the config file is going to potentially have certificates in it. I don't mind that with the database, but I don't like that with the... Well, we'll have to have some sort of scheme. If it starts with file : / for example, then we'll look for a file. All right, that's all good. So new listen config. We're back to this one. And domain. Okay, you know what? We could probably do this. Store the domain, then trim the prefix off of it. So what we're going to try to do is so that we can easily match, for example, we want to be able to match the way that people like to write it is star.example.com, but what we want it to be is .example.com, because star.example.com, we can't do a has suffix on that, but we can do a has suffix on this. Okay. All right, first config exists. And then where's our lint? Strings dot to lower. Ooh. All right, there we go. All right, cool. So lint config is shaping up nicely. That should probably be in its own file. But for right now, we're just going to keep everything in one file so we don't have files scattered all over the place. Oh, we're really close to 11 now. All right. Okay. New listen config. Configs. Okay. Okay, duplicate entry for domain. Wait, that's all the lint config stuff, right? Yeah, I don't really want that. Let me move lint config down. I'm gonna move it down to the bottom for now. Because I don't really want to deal with it. Okay, ineffectual assignment. There we go. Okay, so we've got our config again. Wait, why is this griping? Is there... What's going on? Why is it griping? Why does it keep on coming back to this line? What's wrong with this line? Why does it come back to this line? What is it? What's going on? I don't understand. It doesn't have an error on this line. It just wants to go to this line for some reason. Why? 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 Okay, so. All right, we've got the thing that makes makes the config, has the cancel context. I'm gonna try building this again right now. I think it will. It might build. I'm not. Undefined config. Yeah. So this should actually come back with TLS router.config now. Declared and not used. No, I don't want to put that in there. Okay, we got listen config, we got listen returns a listener. So, do I want listen to return a listener? I don't think I do. I think I want this to be listen and serve. Listen and proxy. And we're not going to return a listener. We're just going to return an error. There we go. Then we're back to this good boy. Okay, so let's try running this now. Cool. All right, so let's see if we can get this thing to do something useful. So lint config. All right, so let's try this. We should get an empty config error. Excellent. There we go. Is it E for error or S for string? I don't know. All right, empty config, great. All right, so all right, let's run again. Okay, example. All right, so let's give it some targets. All right, let's run this and see. Okay, so that didn't work out, which is good. That's the way it's supposed to happen. So then let's go ahead and add an empty object there. Target 0 in domain that has empty. Okay. Address. Okay, let's try address. Just give it something that's wrong. Sucks to suck on that one. One, 2, 7.0.0.1. Okay. All right, and port should be 44433. Yeah, going all out. All right, so that tells us something. So port should be an int, not a string. And really it should be an int 16. uint 16. All right, cool. All right, so we did a little leave read config. We did a little lint config, right? So just for my own sanity, I kind of wish that we could alphabetize. Well, I've done this in the past. We would take this list and we would alphabetize it based on the domain components, maybe. So example.com and example.net should show up next to each other, for example. Wait, do targets not have ALPNs? Alright, I gotta get to bed soon. Target config, ALPNs. Yeah, targets have ALPNs. Oh. I'll do strings.join. ALPNs. I hope I could spell it right. Okay. Okay. All right, what's going on here? Oh, right. Okay, so I need to normalize the config. One thing I forgot to do here is that we do... Wait, I do put the config back in, right? So here's the range, config. Okay, good. So we're going to normalize the config. Which is basically... All right, there we go. So now in the command here, we can normalize it. So we're doing a lot of unnecessary copies and whatnot, but it doesn't matter because we're only doing it on startup. Let's see. All right. Oh. Look at my JavaScript. Whoops. Whoopsie daisies. Whoopsie daisies. All right, what is this upset about now? Oh no, this is for each target. Okay. So this is going to be target, target, target. There we go. Application layer ALPN protocol negotiation. What? All right, so should the default behavior be just to support? Oh wow, got a little spider here. I know a little fish that would love him. Let's see if I can. Where'd he go? There we go. There we go. It's actually shrimp in here, but all the same. Yes, I'm not sure whether I should have the default target be limited or not. I don't think there's too much harm in having it unlimited by default. I guess here's the challenge is if we go through so we want to say any what should the default behavior be? I think the default behavior should probably be that it can only handle these. And the reason for that being is that if you want something that can handle anything, then you would specify that. But we'll see. We'll find out what we like. All right. So normalize the config. That didn't work out the way that... Oh, right, because I did not do the thing that I needed to do, which is to... I didn't update it. So what we want is to have the most specific match. And if we can't get a specific match, then we would take the next best thing. So there we go. There we go. So in this case, both of these would match equally well for HTTP 1.1, but this one would also match for H3. Yeah, that could get kind of confusing. So we could put maybe in an order of preference. Yeah, that could work. That could work. And there's an argument to be made that targets should just be a host. So, for example, 127.0.0.1. But I don't know. I actually don't even want to do that because, for example, all right, what would we do in this case? All right, what's the ALPN? Let me take a look at Webby here. PSQL, ALPN. Well, okay, here's a way we can try this out. Okay, so 4433. All right, handshake. ALPN is PostgreSQL. And in order to keep this simple, we basically have to define what we are willing and not willing to support. And I think it'd be a lot easier to create different variations on the router that have different config syntaxes for the matchers. Like the matching it just becomes highly specific. Maybe it should just be called ALPN, not ALPNs. Well, I guess there's a protocol that becomes agreed upon. All right, until I know better, I'm just going to leave it at ALPNs. Because there will be a single protocol that's agreed upon, and that might be what I want to be ALPN itself. All right, anyway. Let me get rid of all this stuff that I'm definitely not using. All right, so this is shaping up nicely. And since it should never be possible to write to the config, then we should be able to do... Oh, whoops. Right. All right, so is that what I want or no? I don't even know if I want this one. Listener. I don't think I do want this one as of yet. Okay, so here we got LC. Is this where the real config is? There's so many things called config. Oh, why? All right. All right, so now we got some config here. All right. Okay, here's where I could see this working out and making sense. If we had a channel for each group of targets, and we somehow use that to do any updates to the config for that target. I don't know if that, I still don't know if that actually works. Anyway. We could potentially have one of those atomic updates. Yeah, I don't know how we balance between targets at this point. See. Supported protos. You know what I think we do? Is I think we would order it by the server's preference rather than the client's preference. Yep. All right, so ALPN. All right, so we are going to figure out which targets support the thing. I have slices that contains this. Then targets. I'm trying to think, what should this be? Oops. All right, so then I just want to select a target at random. Hmm. So I want to round robin here. Okay, so here's another thing that we ought to do. Okay, so that what I was going to do here is just split this by the server name to see if any match. So what we could do let's see. All right, so we got domain parts. What are these called again? Labels. Called labels. I don't even know why I want to use that. Okay, this is what I want to do. Write the function that will okay, hold on. My config has keys like foo.example.com, .example.com, example.com. Write the go function that will find There we go. That's I think what I want. So I think what we're gonna do is probably a substring with index. I don't know if substring counts as a slice or not. That's one of the things I want to know. No, I didn't want you to do everything. I just wanted to check the one thing. So len labels. Yeah, I don't really want to split and join. Okay, well, you're going too far. Rather than strings dot split and strings dot join, how about indexing and slicing? I kind of want to do it by bytes. Okay. Okay. Yeah, so I don't want to split on labels. Okay. Yeah, so I think we can just do domain equals Okay, hold on. Foo. No, it's only going to check for an exact match once. Because if it's foo dot bar dot baz. It either has to match foo dot bar dot baz or it has to match dot bar dot baz. So we're gonna offset this wildcard here. Okay. Actually, don't think we need to worry about that case either. Okay. Okay, so next dot, there we go. Next dot. Oh, I'm getting tired. It's time to go to bed. Okay, let's see. Okay, so it's possible that there's no dot there, right? So if the next dot is at 0, then this is a no-op. Okay. All right, so if it's at 0, and that's null. But if it's a 1, we're starting where the dot is, right? Wherever the dot is, that's where we're going to start. Okay. So then... Okay, so let's see if I got this right. My brain's a little slow because it's getting a little later, but let me try here, .example.net. Alright, since I'm a little slow on the uptake right now, I'm just going to try testing it. So what we want to try is if I can get curl to do... Can I get curl to do SNI? I think I can. Okay, so what I'm going to do is I'm going to modify my host file. All right. So temporarily example.com and example.net pointing to localhost. So then I'm going to do example.com and stop handshake. Okay. Oops. Foo.example.com. No matching domain. All right, so let's turn this around a little bit because that stop handshake is not very helpful. Found config. All right, so no matching domain found. Found config. Okay. No matching domain found in config. Okay, so we do have a problem here, which is that, well, no, we don't. We're just considering star to be a separate thing. So now I kind of want to say that a target can have multiple domains. I don't know if that's getting too fancy. Or config can have multiple domains. Okay, so then we've got bar.example.net. Okay, found config. So what we should say here, oh wait, what did it gripe about? Nothing. Okay, nothing to gripe about. Good. Okay, so found config example.net. But if we do this, it doesn't find it. Good. And there, it doesn't find it. But here, it does find it. Okay, so that's looking good. All right, so it's midnight. I'm about an hour more into this than I wanted to be. But now what would be nice is to be able to know which of these is the most specific. Okay, I guess that doesn't matter much. Okay. The one last thing I'd like to do I think I'm actually going to go ahead and update this. So we're handling the config file. Well, that wasn't very hard now, was it? Okay, so basically the previous one was kind of the TLS hello world, right? That's kind of what we were at. I'm gonna reword this. Okay, now I don't remember what I just said. I was saying, well, maybe one more thing, but I don't remember what that one more thing was. Honestly, I was gonna say if we could just listen and re-listen to emulate a config change. So there would be a management interface for this. Probably something like localhost. And if we saw localhost or the management domain, then we would something or other. Okay, so listen and proxy. ln config, new listen config. Okay, so I think there's listen and proxy. Let me think about this. Somehow we get a new config. It's probably via API. And we're going to reload. All right. I think what I'd have to do is I'd have to have a channel for accepting these. And then I'd have to have some other way. Let's see. So I could try it with something like, Go funk. Let's see here. Okay, so I can't think about this right now. My brain's not doing too great. But oh, did we have an oopsies? Oh, we had an oopsies. We dropped some frames. Hold on, let's see here. Did we just start a new thingy? No. I don't know. Anyway, yeah, I gotta go to sleep. My brain's kind of closed down. But the thing that I want to figure out is how to have the server stop listening. We'll start listening on a new thing with a new config. Without having the server shut down. So basically this one that we had listening, so this would happen. So we have to prevent that from happening. So it'd probably be something on the inside of this. Something on the inside of listen and proxy. Let's see here. Yeah, we're gonna have to put that into a channel and have a go routine that handles that and have some sort of select here. So let's say we did Hold on, what am I doing wrong? Go by example select. Case. Okay, make select case thingy is thingy. Okay. There we go. Okay, so ignoring that, this is basically we would have some other channel, probably something that's part of listen config. So let's say that we had like a so that we had a done. So case case done would be break. Something like that. Oh, whoops. LC. There we go. Okay. So we'd be looking at something like this. You know, this might be another way to handle it. Rather than having a shutdown, what if I just have a select and have the config updated with the select? I guess the idea is that the config's probably going to get creepy and it's going to start to have too many different places where it might be updated. Right? But to be something kind of like this, where maybe if I could separate the config well enough from the data. Let's see. Could that work out? Because we can only, if we're accepting a connection, we can always proxy the connection. But maybe it'd be this kind of thing where we could read it in. But we'd streamline where... Oh, would we want to do that? Because ostensibly, we could also just say, like, basically this is a loop over this config matching, and whenever we get a hello, you know, like, let's say, for example, we just put that we could put that hello in here and do all the matching. Well, I guess it would need to be... It wouldn't really need to be... I don't know. That seems like that might make it even more complicated. But I was just thinking we could put... Yeah, that's not right. Alright, I gotta go to bed. I can't think straight anymore. It's 12:30. It's bedtime. So, yeah, I'm an hour and a half past where I wanted to be. But I got to have a little bit of fun, think, you know, pre-optimize a little bit. Okay, new connection, bytes read. So next time what we need to do is we need to just get a connection piped from one place to another. That shouldn't be hard. And then after that, we need to figure out our Acme config, which I think is that the Acme Z module. Oh, interesting. Only 10 years late. No biggie. I wonder if he is updated to use that. I doubt it. All right, but is this this is what worries me about it. It's not V1. No, upgrade libDNS to V1. Okay, but what tags are we at? Yeah, I mean, that's a lot of breaking changes. That's a lot of breaking changes. But then again, what have I got over here? That's a lot of breaking changes too. You know, maybe the best thing to do here is actually just to have it go out to an external process, like not actually handle the Acme internally, but just ping something else and use it. I don't know. Oh, interesting. I wonder how long this has been around. If it's a new development or if it's old news. Okay, I want to get GitHub. Three years ago. You gotta love it. Let's see how fast moving this has been. Last week, I mean, that's a lot of movement. Why is this being updated so frequently? Oh, this is the crypto module in total. Okay. But this has got last month. Can we see the history of this? Okay, that's got a few months. And that's got a few years. Okay, so that seems pretty stable. Yeah, so if you look, that's good. There's only been 2 updates in the last 3 years-ish. And before that, it seems like it was in fairly active development. That's okay. But I definitely don't want something that's going to be changing all the time and breaking all the time, you know? So same there. Okay. I'm kind of surprised about that one. Unnecessary byte conversion. Okay, just a little cleanup. And then hasn't had any updates in a long time. Okay, cool. What else? That's funny because that's the name for Acme, but okay. That hasn't been updated in 3 years. That's great. Auto cert. 3 years ago, last month. That's good. 2 years ago. And then I got, yeah, okay. So this is pretty stable. Let's take a look at this other one here. All right. So that's a big breaking change. Means a lot of things aren't going to work. Okay, that's good. Okay. Okay. This is all pretty minor stuff so far. Well, except that's a huge breaking change, but... Okay. Oh no, please don't tell me. Oh, okay, good. Okay, there's a lot of activity on here. Pretty constant. I don't like that. Yeah. I wonder if there's a why not use the Go standard library. Yeah, I might want to go with this one by the Go authors. Okay, anyway, just something to sleep on, I guess. And then where else was I at with this? I'm gonna do something. Okay, yeah, my brain's out. I'm gone. Thanks for tuning in, y'all. Have a good one. Like, sub, follow if you want to. Adios.